Hi everyone, in this video we're going to continue our discussion about complex numbers, but in this one we're going to talk about the process of dividing as well as using the conjugate to find that divisible value. Now, complex numbers are unique because we don't really have division in the same sense we have a standard division process. If you think about actually dividing any numbers, 6 divided by 3 is 2, because there are 2 groups of 3 in a set of 6. So if I had 6 things, that's one group of 3, that's the second group of 3. So that's how we're actually doing division. But I can't do that when I have something like 5 and it doesn't quite work because one's a real number and one's an imaginary number, so you can't really split them into groups. But we use something called the conjugate. And so our conjugate is a really easy process to find. And it's quite simple in that if I have any complex number, a plus bi, where a and b are any numbers, its conjugate is a minus bi. And vice versa, if I have a minus bi, its conjugate is a plus bi. The key to this is seeing that it's the complex part that changes. Not whatever number comes second, it would be whatever the complex number is. So, in this case, I look at my first example, 5 minus I. I is a complex number, so i's conjugate is negative I. And so what I'm going to do is I'm going to multiply both numerator and denominator by negative I. And I times I is I squared, and positive times negative is negative. And as you recall, I squared is negative 1. Which means negative I squared is actually positive 1. And so we're left with this result, negative 5I. So we want to actually think of complex division more as a rewriting, so it's not in a fraction form anymore. We're not quite doing division, we're just finding another way to write it, but that's how we call it. So let's get our next one, 3 over 1 plus 4I. So I'm going to multiply by 1 minus 4I. And 1 minus 4i, because that's my conjugate. I'm going to distribute the 3, so I get 3 minus 12i. Now, in the denominator here, we're going to use the distributive property. Now, you're going to see something. I'm going to do it once, but I'm going to kind of not do this again, or distribute all the terms, but 1 times 1 is 1. 1 times negative 4 is negative 4i, positive 4i, and then this becomes negative 16i squared. And so what you would notice is every time you distribute with conjugates, the middle terms will cancel. So whenever you do the conjugates, you actually just need to do the first and the last term. And so negative I squared would be positive 17. So I end up with 3 minus 12I over 1 plus 17. 3 minus 12i over 18, and everything is divisible by 3, so I'm going to reduce it, so 1 minus 4i over 6. Now, my third example here, you already can kind of see that it's not quite in the form that we want, so I'm going to rewrite this. So it's 2 plus 3i. And now I can use the conjugate to multiply by 2 minus 3i in both numerator and denominator. And again, now the top part, they look similar, they're close to conjugates, but for the sake of this, let's actually multiply it out. Negative 2 times 2 is negative 4. Negative 2 times negative 3 is plus 6i. 3i times 2 is plus 6i. 3i times negative 3i is negative 9i squared. So these didn't quite cancel. We did get some combining in the middle and the edges, but it doesn't quite work the same way as the conjugate would here. 2 times 2 is 4. Remember, the inside and the outer terms are actually going to cancel. If you want to multiply it out, go for it, but you're going to see you're going to get a positive 6 and a negative 6i. And then here I get negative 9i squared. So let's just clean this part up. Negative 4 plus 12i. This now becomes plus 9. And this also becomes a plus 9. So I get 13 plus 12i over 13. And so here's 2 examples if you want to try. I'm not going to walk through every single step like I did with the previous ones. But if you want to pause the video now, would be a good time to try it. Okay, so I worked out all this, and so I'll kind of highlight some of the important parts. So I multiply by the conjugate 3 minus 9i. I distribute the top, distribute out the denominator, and I end up with 18 minus 54i over 90. Each one of these is divisible by 9, so I divide them by 9, and realize they're actually divisible by 2 as well, so I divide by 2, leaving me with 1 minus 3i. Now in this one, I have to multiply by the conjugate, 5 plus 3i. Again, I just use my little shortcut here. 5 times 5 is 25. Negative 3i times negative 3i is negative 9i squared, giving me 34 in this denominator. Foiling out the top here, I end up with 35, 21i, 10i, 6i squared, which combines all together to give me 29 plus 31i. Now, if you are interested in seeing why those cancel, a plus bi times a minus bi, if you actually just work this algebra out, just to kind of prove to you why these middle terms cancel, in case you're interested in such a thing, b squared I squared, you see it right here, and no matter what a and b is, they cancel, and I squared becomes positive, so b squared, and so you end up with that it comes a squared plus b squared. Kind of similar to the difference of squares formula. All right, I hope that was helpful, and that wraps up our little mini lesson on complex numbers. Thanks. See you in the next one.